If the human brain stops functioning for exactly 60 seconds, the results are catastrophic. Within seconds, consciousness vanishes as the electrical grid of the body goes dark. The brain stem, the autopilot of the human machine, stops sending signals to the diaphragm, causing immediate respiratory failure. While the heart has an internal pacemaker, it loses its primary regulator. Blood pressure collapses, and the body enters a state of deep clinical shock. Without the brain to manage basic reflexes, the body's self-preservation systems fail entirely. By the end of 1 minute, the chemical balance required for life begins a terminal descent. This rapid collapse occurs because the brain is the body's most demanding engine. It accounts for only 2% of total body mass, but consumes 20% of its oxygen and glucose. It has zero capacity to store energy, requiring a constant, high-pressure stream of blood to maintain its 86 billion neurons. These neurons communicate via action potentials, electrical bursts traveling at speeds up to 270 miles per hour. This high-speed network allows for the near-instantaneous processing of reality, but a 1-minute break in communication causes a cellular traffic jam. Without a constant flow of ions, neurons lose their structural integrity, leading to rapid malfunction. To move from simple survival to high performance, you must understand a specific region called the anterior mid-cingulate cortex, or AMCC. This area is the hub of tenacity. Research shows the AMCC physically grows when individuals perform tasks they find difficult or unpleasant. When you choose the hard path, you are physically expanding the part of the brain responsible for willpower. This is the biological difference between a mind that avoids friction and a mind that seeks it. The modern environment creates a dopamine trap. Constant stimulation from cheap sources like infinite scrolling or high-sugar foods raises the dopamine baseline to an unnatural level. This creates a deficit state where effortful tasks feel physically repellent because they cannot compete with instant gratification. To force your brain to crave hard things, you must intentionally enter the friction zone, the period of intense mental resistance at the start of a difficult task. This friction is the feeling of neural pathways being reconfigured. By pushing through this discomfort, you activate the prefrontal cortex and trigger a slow-release dopamine response. This creates a new feedback loop where the struggle itself becomes the signal for a reward. Over time, the brain stops associating effort with pain and begins to associate it with the profound satisfaction of competence and control.